Hello, ladies and gentlemen. Today we are going to take a closer look at just the angle shortcut here for similar triangles. So today we're just going to focus on that angle and understanding that a little bit more. So you need your calculator, something to write with, as well as your notes. You can jot down a few examples that pertain to our lesson today. And we won't have a lot to write, but it is important that you write these things down, okay? So to know that you have two triangles that will be similar, remember we've talked about the three shortcuts, but the one we're focusing on is the angle-angle similarity postulate. And so all the angles must be the same, and then the sides will be proportional. You don't even have to check them. This is called angle-angle similarity. Okay, angle-angle similarity. It means that the triangles will be similar, but remember angle-angle was not a way for triangles to be congruent, but it does guarantee that we will have similar triangles. So this is what it would look like in a picture. So if you had two triangles like this and they were marked with two angles that are corresponding and congruent, like you see in this picture, then we know for certain that the triangles are similar to each other. We know that triangle JKL is similar to triangle XYZ. They are not congruent, but they are in fact similar, so their sides will be proportional. So are these two triangles similar? Well, let's take a look and kind of analyze this diagram a little bit. You want to write this one in your notes, okay? We have one set of parallel lines here, two parallel lines. And when you remember parallel lines, please remember that we have angles that are in fact congruent. So angle G is congruent to angle N because they are alternate interior. Angle H is congruent to angle M because they are alternate interior. And we can also justify here that these angles at angle K here, on both sides of K, would in fact be congruent because they are vertical angles. So we would say, yes, the triangles are similar. The triangle GHK, let's say, is similar to triangle NMK. And we would know that by the angle-angle similarity postulate, that we see that their angles are congruent in each set of triangles here. They have corresponding angles congruent, therefore they are similar triangles. What about these two? Well, we have a 77-degree angle, a 48-degree angle, and on this one we have a 48-degree angle and a 55-degree angle. So at first glance it looks like no. But please remember that in triangles there are 180 degrees. So if we did the math and calculated 77 and 48, and then we went ahead and figured out how many degrees were left, we'd find out that angle C is in fact 55 degrees. So we would know by finding these missing angles that they do in fact match up with congruent angles like they're supposed to. We would say angle D here matches up with angle A. We would say angle C matches up with angle F. And we would say angle B matches up with angle E here, just based on those numbers. So we would say that triangle ACB is similar to triangle DFE by the angle-angle similarity postulate as well. Now if we look at a third example of this time when we go ahead to figure out if the angles here or these two triangles are similar, we need to be checking those angles, and I noticed right away that this 32-degree angle and this 33-degree angle, they are not going to be congruent. So we would say no, these triangles are not similar. So let's take a look at one more example you need to get into your notes. Here's a picture of two triangles, and we're being told that they are in fact similar. Triangle MON is similar to triangle, now be careful, we'd want to put these in the correct order, triangle GHI. Now that means we can match up their corresponding sides. Not that the sides are congruent to each other now, that's angles, right? But we would say the sides are proportional. We see the two congruent angles, M and G, O and H, so we know these two triangles are in fact similar by the angle-angle similarity postulate. Okay, we can see that. But now when we match up the sides are not congruent, they're proportional. So MN would match up with GI. They would make a ratio. ON, that side, would match up with HI. And MO would match up with GH. Now, if we match those sides in a proportional relationship here, this 16 would go with the 12, or correspond with the 12 in the smaller triangle. just like something corresponds with to 10, and that would be x. So if we went ahead and cross-multiplied here, now we've been doing this for a while. Cross-multiplying is nothing new. In fact, you've solved much harder problems than this in recent days. So when you go ahead and cross-multiply, let's remember that we take 16 times 10 is 160, 12 times x is 12x, and then you're going to go ahead and take 160 divided by 12, and you get x equals 13 and 1/3, or 13.3 repeating. Okay? Now, when we set up the next ratio, let's look again. What goes with 16? Well, that would be 12, just like 8 goes with y. So if we cross multiply that, we'd have 12y, and then 16 times 8 would be 128, and then we divide by 12, and we end up with y to equal 10 and 2/3, or 10.6 repeating. And this one up here was 13 and 1/3 if you'd like that as a mixed number. Okay, so we can solve for x and y as long as we see that we have similar triangles, but we'll be checking to make sure we have similar triangles beforehand because we may not always be told. Okay? So the importance of understanding similar triangles is recognizing that there are applications of this in the real world, like low light camera lenses. The whole purpose or the whole idea behind those lenses there, it actually makes a little miniature version of what we see in that image, what we're taking a picture of. But the miniature version is upside down, and there's mirrors inside a camera, and those sorts of things are pretty complicated things to figure out. But that whole idea of making similar figures, right, and similar triangles are involved in diagrams of how cameras work. Now, similarly, we can go ahead and use similar triangles to help us find measurements of things that we can't measure directly, so indirect measurement. So to find the height of a tree, for example, you'd want to put this one in your notes. Let's say we place a mirror on the ground and we look down at the reflection that we see and back up until we see the top of the tree. If you walk backwards, you'll be looking in that mirror, looking downwards now, at a certain degree, I guess, if you want to call it that, and then that light reflects off the mirror and bounces back up to show you the image of the top of the tree. And we would go ahead and say that these two angles are in fact congruent because of that whole reflection piece. If you understand how reflections work off of mirrors, the angle the light hits the mirror is the same angle it's reflected off. And we also notice that in each of these triangles I have a 90-degree corner as well. So we have angle-angle similarity happening for these two triangles. So why are they similar? Because I set up angle-angle similarity. And because now I know that they're similar, I can use those two triangles to help us find the height of a tree. Now, we wouldn't climb the tree and drop a tape measure down, but we could use this idea of indirect measurement, drawing out a diagram, seeing the geometry principles in there, to find the height of the tree. So now if we were going to set up something to cross multiply here, we would say my height of 5.5 feet matches up with the height of the tree, h, just like the distance I am away from the mirror, 3 feet, matches up with the distance the tree is away from the mirror, 24 feet. And then we would go ahead and cross multiply this. 3 times h would be 3h. 24 times 5.5 is 132, and we'll go ahead and divide by 3, and we find that the height is 44 feet. Okay, so we can use similar triangles to find things that we cannot directly measure. Another idea, what about the diameter of the sun? Can't really measure that, right? So to estimate the diameter of the sun, you punch a tiny hole in a piece of paper and you hold the paper so the sun shines through the hole onto a screen with a surface perpendicular to the direction of the sun. So you have to be careful to hold that paper just right so that you aren't angling the paper. And using the information that you create now, you can see that it projects a little miniature version of what would be the sun, or using the sun's rays. Okay, we can measure certain things in here now, and we can go ahead and figure out the diameter of the sun. Think about how we would know if for certain that these two triangles would be similar to each other. Well, let's think about those angles, right? We have 90 degrees here, and we have a 90 degrees here and here. And would this angle be congruent to this one? I'm not sure, right? I mean, that's kind of tough. They're not quite vertical angles. The whole angle here would be congruent to that whole angle there. But we do have, whoops, parallel lines here and here, right? And so we would know for certain that this angle and this angle would be alternate interior angles. So yes, we have triangles that are similar by the angle-angle postulate. And then we could go ahead and solve to find that diameter of the sun. Or in our case, we could use our information here to figure out the diameter of the sun by setting up something we could cross multiply. The diameter of the paper, the length of the projection here, and the length or distance from the sun to the paper, and then we could go ahead and use that to find this x that we don't know. Okay, so let's set that one up, and then you can go ahead and solve that in your notes, and I'll be checking that when I check your notes tomorrow. Okay, so let's set up the diameter of the sun, not sure, would match up with the diameter of the paper, just like the length in the sun's triangle there, 150 million kilometers. That was a lot of zeros. I had to think while I was writing. Matches up with the 200 centimeters. Okay, now I want you to think about setting that up and cross multiply to solve. And x equals, you figure that out, and I'll be checking your notes tomorrow, okay? Thank you very much for taking good notes today.